In my previous lecture, I was telling you about the concept of electric flux, and in that concept I told you that flux is dot product of electric field intensity and area vector. Some more thing I want to include here. If you break this, it will come EA cos theta. For a constant electric field region and area of the coil, you can see here flux depends upon this particular term, that is angle between the intensity and area vector. Due to this, flux is of three types. Electric flux is of three types. Number first is positive flux. Number two is negative flux. And number three is zero flux. You can understand by changing the value of theta, you will get all these three. Question is when it is positive flux. When angle is more or equal to 0, less than 90 degree, then always flux will be positive. Negative, when angle is more than 90 but less or equals to 180 degree, then it will be negative. And 0, when angle is exactly 90. Angle means what? Angle means the angle between the direction of intensity and area vector. So this is the overall concept of electric flux. Now the question is Gauss theorem. Gauss theorem is the very important theorem to calculate the electric field intensity due to charge distribution of any shape of body. Okay. So first of all, understand the definition of Gauss theorem, this statement of Gauss theorem I am writing here. Gauss theorem is what? Total electric flux associated with a closed loop is always equals to the 1 upon epsilon naught times of total charge associated by that loop. This is the statement of Gauss theorem. Total electric flux associated with a closed loop is always equals to the 1 upon epsilon naught times of total charge associated by that loop. In mathematical way, total electric flux, that is phi, equals to 1 upon epsilon naught times total charge, let the charge is q. This is the mathematical formula of Gauss theorem. This you can also write in this way because you have already studied flux is vector E dot vector A will equals to q upon epsilon naught. In this way also you can write Gauss theorem. Flux, this formula we are using, electric field intensity is uniform, or you can say area is constant. Suppose that if area is not constant, it changes. Then what happens? Then this formula will be written in this way. Flux is integration of vector E dot vector A. If you consider a small area of that particular portion, so in place of A, symbol is used ds. And because surface is closed, so we use the symbol close. Okay? And because it is surface integration, so we put here S sign. Then the formula Gauss theorem can be written in this form also. Surface integration vector E dot vector ds is 1 upon epsilon naught times total charge q. This is phi. In this way you can define Gauss theorem. There is a derivation of Gauss theorem. For derivation, suppose that a point positive charge is present in the space in a spherical shaped body, inside a spherical shaped body. So it will give this direction of electric field in this way. You have already studied y in this way, radially outward in this way. This is the direction of intensity. Direction of intensity. Radius is, suppose that r, radius of that spherical body, suppose that r. This point is taken as a small area element. This point is taken as a small area element. It is as much small as the point is present here. Let this small area element is ds. It also possesses direction because it is area vector, outward direction. Now, this point is at r distance from here. So here intensity will act. So that intensity E will be 1 upon 4 pi epsilon naught. Charge is Q divided by R square. If you want to write in vector form, then here let the unit vector is R cap. Now, vector E multiply with dot product with the area vector ds. You will get 1 upon 4 pi epsilon naught Q upon R square R cap dot product of vector ds. For vector ds, assume unit vector n into ds. Now integrate both sides to calculate whole flux here. The surface is closed. I have drawn this figure here. Now here also sign of integration. Now this is q is constant, 4 pi epsilon naught r square is constant. Two unit vectors are there. Dot sign is there. Means answer will be 1. So you will get q upon 4 pi epsilon naught r square integration is close integration ds. When you integrate this ds, what you will get? You will get close integration. This is left hand side vector E dot vector ds. Here q upon 4 pi r square epsilon naught into 4 pi r square. This is surface area of this sphere. 4 pi r square will cancel. You will get q upon epsilon naught. This is derivation of GAUSS theorem. In this way you can derive GAUSS theorem. This GAUSS theorem is very important, which is used to measure intensity of different shaped body. In my next lecture, I will tell you about the application of GAUSS theorem. Okay, God bless you.